for this. Okay. So you see my screen right now?
Yep.
Good. So let's do just a normal neural network. You define it somewhere over here, build it with the sequential. Then you say, well, when you compile it, what you need to do as loss function is this categorical cross entropy. The optimizer, what you are trying to optimize is this RMS propagation. And the metric that you want to be displayed is accuracy, right? So when you run it, which is this fit over here, for each of the epochs, it will tell you what is the loss value, the accuracy, and in the validation sample, it tells you what is the loss and accuracy, right? And at the end, once it's done on the learning, you can ask to your model that is fit already, it has done the fit, is to evaluate on any other data set. In this case, it's X-test and Y-test. And what it does is with X-test, it finds what is the prediction from the model, sees the difference with the true labels, which is Y-test, and then it tells you where is the accuracy that you had on that one. Okay. And here is just plotting what happened during all these epochs. Is this clear, Jesus?
Yeah.
Very good. And,
Sorry?
yeah, go ahead.
Yeah, I have a question about the accuracy and the loss functions because they do not sum one. And I went through the Keras documentation and I didn't understand it very clearly.
The accuracy or the loss function?
I mean, I thought that accuracy plus loss should sum one, no? Or
No, they don't. So loss is the loss function, is the cost function.
okay.
What you want it to be as small as possible.
But it is not like the rate of fails.
No,
Okay, no, it's just the okay.
It's the name is confusing. It's called loss when it's actually the cost function.
Yeah, the entropy or so. Okay.
Exactly.
Okay. And can I do another question?
Sure.
This algorithm, in order to fit the weights, what they do is backpropagation, or
yes. That's something I didn't cover on my lecture. Yes, that's right.
Okay. Thank you very much.
I thought of maybe explaining to you what is the procedure of backpropagation. There is this when you run through the network, like every time you go layer to layer, you are activating with new weights and new biases. And there is a procedure of estimating the error that you are making each time using this backpropagation formula. The derivation is not particularly illuminating, and it's not that you are going to use this in practical application. So I decided not to cover that. But there are plenty of references I can send you if you want to look at it, and we can discuss in private as well. Okay. Anybody else wants to share?
A question about the optimizer.
Yes.
Because the the backpropagation is the optimizer field in the model or not?
No, the optimizer, the one that you choose to use. In that case, so let me see at the beginning.
It's RMS
prop. Yeah, there are different types of, for example, RMS prop is one. I often use Adam. SGD is another optimizer, but yeah, you have different options. And depending on your data set, you might want to use one or the other. There are like rules of which one you might want to use depending on the characteristics of your problem. But in my experience, at the end of the day, the results do not depend that much on the choice of the optimizer. There are more important features in your choices. For example, what somebody had already shown that if you start adding dropouts and regularization, the learning becomes better. That's more important, I would say.
Okay, but with the optimizer, is the way to calculate the loss function, or
is the way that you remember that the neural network at the end of the day is just trying to do a minimization problem. It's optimizing a minimization problem. You want to find the minimum of the loss function. And whenever you are trying to find a minimum, you are trying to do it with some criteria, like do you go in small steps, or do you maybe also take into account the derivative or second derivative of your cost function as it arrive to that point? Like all these different criteria you might use to find as fast as possible your minimum. So to get here, also there are different ways of doing it, and this is HGD stochastic gradient descent or ADAM or RMS probe and so on are different ways of doing that.
okay, I see, thanks.
So, I mean, hopefully, if the ones that had time to go over the notebook, played with with a regularizer, played with the number of neurons in the different layers, number of layers, deepening the neural network, making it shallower, seeing whether there were any differences. Hopefully, you also played with the data augmentation. I was asking you a question in the notebook, is that when you use data augmentation, one of the things is that you can do is to start twisting the images with an angle. And one of my questions was whether there is any limitation on doing this. Like, for example, the angle I put over there is like 10 degrees or 15 degrees. Do you think if I could do any kind of angle rotation in my images? Like, I'm going to ask anybody.
I mean, it has to be a maximum angle, because if not, at some point the nines will start to be 6. So
very good. Yeah, exactly. And you know, you can do that if you put a large angle so that the 9s and 6s start not being distinguishable. Your performance is going to go, accuracy from 99% is going to be to 80%. Because there are two categories that you are going to not be able to distinguish from each other. So that's a nice thing to try also. Very good. And any more questions, comments about this CNN notebook? And if not, I guess some of you, well, I can see it in Slack, you are trying to run the SUSY examples. I don't expect that any of you will be able to finish this during this hour and a half you have. But along the day, you keep trying, or in the next few days, and you have any questions, send them through Slack, okay? I see that some of you already encountered an issue when you use TensorFlow, is that it's like Python 2 to Python 3. Why do they change versions and then lots of the syntax is changed and it's then incompatible? Same is going on with TensorFlow. Now the default version is the new one, which is TensorFlow 2, and is sometimes incompatible with TensorFlow 1, which is what is used by these people in the SUSY analysis notebooks. So that's something that I can see that some people are already finding the solution to that, which is to fix the version to the TensorFlow 1. So yeah, keep going, because this is the kind of stuff that you are going to encounter whenever you want to use notebooks from other people. They will be in different versions and so on. And if not, I'll see you tomorrow and we'll discuss about unsupervised machine learning. Okay. All right.